German word is Gedanken, to use logic to lead yourself to an answer that you could, of course, confirm later worked. We're going to use that technique in this part of the assignment. Gasoline pumps correct for volume and temperature. It also adjusts the recorded volume delivered given the temperature. If you inspect a gas pump next time you're there, you will see a Department of Weights and Measures listing the correction values for the pump. And the limited use we made of labware in the time school was in. You saw a lot of the labware said 20 degrees Celsius on it. But many consumers believe that by buying gas on cold days, they will get more volume and therefore more gas because the gas will expand when it warms up. But what really determines your driving distance? The volume of the gas or its mass? And which of these properties is unchanged by temperature? So let's do our thought experiment. Let's imagine the weather changes from 20 degrees to 1 degree. The gasoline contracts. What has changed in that canister? The volume or the mass or the density or all of them? Well, the shrunken volume of fuel represent less gasoline energy. And here's the thought experiment part. If you flatten a sandwich, do you get less calories? Now, if the pump corrects for this shrinkage, you pour 10 liters in wintertime, which gas can represents the corrected volume? So over here on the left is your 10-liter can in summertime. That's the 10-liter mark. Then you go there in wintertime when the gas is contracted. Which of these will represent what you get now and causes you to think you've been ripped off? If the pump is correcting for volumetric expansion, meaning it's delivering the equivalent of 10 liters at 20 degrees. So when you buy the gas at 1 degree, it will dispense for you what would be 10 liters at 20 degrees. Will you get the same volume of gas as you do in the summer, or the same mass of gasoline as you would get in the summer? Are you able to drive less distance on 10 liters of winter gas even though it has contracted in volume? So once again, this is our sandwich. Normally, we squish the sandwich. Do you lose any energy in that sandwich?